Welcome to Module 3 of HNAS 699. This first mini lecture will be on measuring central tendency and variability. In this module, we'll be looking at calculating and interpreting simple descriptive statistics, determining and calculating the appropriate measure of central tendency for a set of data, and understanding the concept of variability, calculating and interpreting different forms of variability measurements. So when we think about descriptive statistics, we might wonder, why are they important, right? Descriptive statistics include things like measuring mean, median, mode, etc. And when we have a list of data that we've actually just collected, that list of values isn't very informative, right? If you have 100 individuals that you've been making observations on, that's a lot of information to process. And so descriptive statistics allow us to simplify, summarize, and describe these data sets with some measure of central tendency, so the mean, median, and mode, for instance, and also measures of variability. And in a little bit, we'll talk about some examples where the means might be similar, but there's differences in the variability and how that can be informative. And when we look at descriptive statistics, we're looking at a statistic, right? So statistics come from samples, and what we want to estimate is parameters. So remember, populations have parameters. These parameters are written as Greek letters. So here we have mu and rho, and statistics are represented by Roman letters. So example, for the mean here we would have x bar, and an estimate of the standard deviation would be s hat. And note, this will come back later, but that equations that we use to calculate parameters versus statistics can actually vary a little bit, and they're calculated differently. Your textbook goes into measurements of mean, median, and mode, and these are very common, so I'm not going to spend time on them here. But when you use these different measurements, so the mean, median, mode, will really depend on the scale of measurement that was covered in an earlier module. So when we have ratio data that has a zero value that's meaningful and all the numbers are meaningful and we can do lots of mathematical calculations on them, we can do mean, median, and mode. Similarly with interval data, but once we start getting into data that's more categorized, the mean is no longer meaningful. And when we have nominal data, so when we have different categories or colors, well, figuring out a median and a mean are not informative at all. So I'm not going to go into calculations of the mean, median, and mode, but I will cover when the mean and the median are when we have symmetrical data versus skewed data. So when we have symmetrical versus skewed data, the meaningfulness of the mean and the mode are going to be different. So if here we have something that looks quite symmetrical, like a normal distribution, we're going to have frequency on our y-axis and the value or our score on the x-axis. And when we're looking at data like this, the mean, because it's a symmetrical distribution, is going to end up in the middle. That's going to be our mean value. But also the median is the middle value, right? So 50% of the data will be greater than that value, 50% of the data will be less than that value. And so this point here in the middle will represent both the mean and the median when we have symmetrical data. However, when we have data that's skewed, like this, again we have score on our x-axis and frequency on the y-axis. Think about where the mean is going to fall in this case. Right? So the mean takes into account all the data across the whole range. And it might be somewhere like this. This data is left skewed or negative skewed, and that's our mean would be approximately there. And then the median, because it's the middle value, would be closer to that hump, right? Because this is frequency on our X. So there's a lot of data contained over here. When we have data, I'm just going to slide this up. When we have data that has a right skew, or it's positively skewed, a similar pattern here is going to follow. So we're going to have our mean, and then again the median is going to fall closer to the hump. And so when we look at data, here we have examples where we have symmetrical and skewed data, and the mean and the median will fall in different places. And that's going to conclude the first part of this mini lecture. The next part will focus on variability.